Chapter 20 is electrochemistry, which is all about the relationship between electricity and chemical reactions. Section 20.1 starts with a review over the oxidation reduction reactions or redox reactions. The main thing to remember in redox reactions is Leo says grr. So loss of electrons is oxidation, gain of electrons is reduction. To figure out whether something is undergoing oxidation or reduction, you have to trace its oxidation states or its oxidation numbers. Remember that oxidation numbers are not charges. The only thing they are used for is to figure out whether something's undergoing oxidation or reduction. There are a few little rules here that we need to know. If it's a free element, its oxidation state is 0. If it's a monatomic ion, like a sodium ion in sodium chloride, then its oxidation state will equal its charge. Oxygen is almost always -2, unless you have a peroxide like hydrogen peroxide, then it's -1. Hydrogen is almost always +1, unless it's bonded with a metal, in which case it's -1. Fluorine is always -1, and the oxidation states of neutral compounds have to be 0. The oxidation states for charged compounds, polyatomic ions, must equal the charge. So for example, if we were looking at hydronium and we add together the oxidation states of hydrogen and oxygen here, hydrogen's a +1 and there's 3 of them. Oxygen's a -2 and there's 1 of them. Add them together, you get a +1. That is equal to the charge of hydronium, +1. Other things to remember here is that your oxidized substance, which is losing electrons, its oxidation state is said to be increased, and remember that it either is or is part of the reducing agent. It seems kind of weird that the oxidized substance is the reducing agent, but remember that when something is oxidized, that means something else is being reduced, and the thing that is being oxidized usually is forcing the other thing to be reduced. Therefore, it is the reducing agent because it forces something to be reduced. Alternatively, the reduced substance is part of the oxidizing agent. Now, anytime something is oxidized, something else has to be reduced. There has to be both things going on. For example, here I have magnesium with an oxidation state of 0. Going to an oxidation of +2, so it has lost electrons. Here I have hydrogen going from +1 to 0, therefore it has gained electrons. And so magnesium, since it lost electrons, is oxidized, Leo. The hydrogen, since it gains electrons, is reduced, so Gur. The magnesium, since it was the one that is oxidized, is our reducing agent. Hydrogen is a part of hydrochloric acid. Hydrochloric acid is what forces magnesium to lose its electrons, therefore hydrochloric acid is the oxidizing agent. So very quickly to run through some examples, we're going to look at a combination of sodium and chlorine, identify oxidation numbers, and identify what undergoes oxidation and reduction. We'll also go ahead and do the oxidizing and reducing agent. So start with our equation. After you have your equation, you have to assign oxidation states. Sodium and chlorine are both free elements, so their oxidation states are 0. Sodium chloride has 2 monatomic ions in them. The charge of the monatomic ions will be equal to their oxidation states. So chlorine's -1, sodium's +1. Once you have this, you can trace what happens to their oxidation states. So if I trace what's happened here, sodium goes from 0 to +1, so it has lost electrons, so it was oxidized, and chlorine has gone from 0 to -1, so it has gained electrons, so it was reduced. Since chlorine is the one that was reduced, the thing that forced it to be reduced was sodium, the thing that reacted with it, and so sodium is our reducing agent. And since sodium was the one that was oxidized, chlorine was the one that reacted with it, so chlorine is the thing that forced it to be oxidized. It's our oxidizing agent. And now let's take a look at another one. It's a little more complicated. You start out the same way with your balanced chemical equation. And there's no real way in this example problem to tell what the oxidation state of iron is going to be. Let's just go ahead and make it iron 2. Okay, and now we're going to trace oxidation states. Iron is 0 and nickel is 0. Those are the two easiest ones. Next two easiest ones are monatomic ions. Nickel's a +2, iron's a +2. Nitrate is the hardest one out of all of this, but really the nitrate isn't a big deal anymore because we already can see which one's being oxidized and reduced, and since nitrate stays nitrate throughout the entire reaction and never changes, that means its oxidation state is not going to change either. But if I wanted to go ahead and do it, oxygen is a -2, and the nitrate ion has a charge of -1, which means that the nitrogen is going to have to be +5. It's going to be the same on this side too. Once I have this, I can go ahead and trace my oxidation states. Iron goes from 0 to +2, so it has lost 2 electrons, so it has undergone oxidation. Nickel has gone from a +2 to a 0, so it has gained electrons, so it has undergone reduction. Since nickel was reduced, the thing that made it be reduced is the thing that reacted with it, iron, so iron's our reducing agent. And then iron was oxidized, the thing that reacted with it is the thing that forced it to be oxidized, that was nickel nitrate, and so nickel nitrate is our oxidizing agent.